This is 4.3b. 4.3b. All right. So x to the 1/3 is exactly the same thing as the third root of x. So radicals, square roots, third roots, and everything, they're really just exponents. And you probably knew that. But, so you knew that that 3 went there, but this 1 goes here as well, which means if we had x to the 2/3, that's actually the third root of x squared. Okay, and there's some debate on whether or not that squared should go inside or whether it should go outside. And for the purposes of this class, it doesn't really matter. But remember in the last one, we ran into the weird situation where we had to use absolute values. So whether it goes in or out, you may need absolute values, and it gets a little bit tricky, but we're not going to be super specific in this class. So here, this is the third root of 27. 27 is made up of a triplet of 3's, so we bring that out. Nothing's left on the inside, so the answer is 3. The next one is 81, or the fourth root of 81, and 81 is just 4 3's multiplied together, so the answer is 3. Okay, so here we have the square root of 25 to the third. Now, should I put the 3 on the inside or should I put the 3 on the outside? And it sort of just depends. Can we take the square root of 25? Yes. So I would prefer this method for this particular problem. The square root of 25 is 5, and then we raise that to the third power, and we get 125. Okay. Now, if we did it the other way, 25 to the third is 15625. And what is that made up of? Well, it's made up of 25 times 25 times 25, right? And each one of those is a pair of 5's. And what am I looking for? I'm looking for sets of 2. So I have 3 sets of 2, which means my answer is 5 to the third, which is 125. Now, there's another way to do this. I just showed you 2 ways. Let's think about this. 25 to the 3 halves. Can 25 be split into 2 equal multiplications? Yes. 25 is 5 times 5. How many of those 5's are going to be in my answer? 3 of them. So this tells me what to split it into. It doesn't mean divide by 2. It means can 25 be written as something to the second power? And then my answer has 3 of those, so the answer is 125. So any one of those methods is going to work. Okay. What if I had 81? No, let's not do that. Let's do 27 to the 2/3. So that is the third root of 27 squared, or the square of the third root of 27, or we could do it the other way. 27 squared is some big number, I don't know, is 729. And what is this made up of? 27 times 27, which is 3, 3, 3, 3, 3, and 3. What am I looking for? triplets? I have a pair of triplets, so the answer is 9. Okay. Another way to look at it, can I take the third root of 27? 3. And the answer is just 3 squared, which is 9. Or, my preferred way to look at it, can 27 be split into 3 equal multiplications? Yes. 3 times 3 times 3. How many of those are going to be in my answer? Just 2 of them. 9. Okay. So what about 32 to the 2/5? Can 32 be split into 5 equal multiplications? 2 times 2 times 2 times 2 times 2. How many of those are in my answer? 2 of them. So 32 to the 2/5 is 4. I'm using 2/5 of the equal multiplications. Okay. What if we had 49 to the 5/2? So it's 7 times 7, that's 49. And I need 5 in my answer, so whatever that really big number is. Okay, does everybody understand that? Ooh, big number. Okay. Yeah, I'm sure you did that in your head. We believe it. Okay. Suppose that a wave forms in shallow water. The depth of the water and the velocity v of the wave are related by the equation the velocity equals the square root of 32d. If the wave forms in a water with a depth of 7.5 feet, what is the velocity? So all you're going to do is stick that in there and then round to the nearest tenth. Okay. So if I had x squared times x to the third, what is that? X to the fifth. Why is that? Well, I have x times x times x times x times x. So really, I'm just counting up how many x's I have. What if I had x squared to the third? So what does that mean? Well, it means I have 3 of these. And now when I count up my x's, I get x to the 6th. So when the bases are equal, what do we do with the exponents? Add them. And what happens when we take an exponent and raise it to an exponent? We multiply. So here, y to the 6 over 7 times y to the 1/2 is going to be y to the 6 over 7 plus 1/2. So that would be 12 over 14 plus 6 over 14. Did I do that wrong? Oh, 7, thank you. So we get y to the 19 over 14. This is called the product rule. If the bases match and you multiply them together, you add the exponents. Okay, here is the power rule. So this is saying u to the 4th this many times. So anything with an exponent raised to an exponent, we multiply those together. So it's u to the 4th times 5 over 8. That becomes u to the 5 over 2. Okay, which could be written as the square root of u to the 5th, or the square root, the 5th power of the square root of u. That's not what it wants you to do, but that's where we're headed. Okay, quotient rule. y to the 3 over 5 divided by y to the 3 over 4. So this is going to be y to the 3 over 5 minus 3 over 4. Right? If the bases match and we multiply, we add the exponents. If the bases match and we divide, we subtract the exponents. So common denominator is 20. So 12 over 20 minus 15 over 20. Oh, I didn't see this coming. So that's y to the negative 3 over 20. Yeah, I don't want negative exponents. So 1 over y to the 3 over 20. So what I should have done is subtracted in this direction, right? So it should have been 1 divided by y, 3/4 minus 3/5. And that gives me 1 over y to the 3 over 20. I wasn't thinking when I did that. Okay. This is why x to the 0 equals 1. Did you guys know that? If I had x to the 4th over x to the 3rd, that's just x to the 4 minus 3, right? But what about x to the 4th over x to the 4th? Well, I just bring this up, and I get x to the 4 minus 4, which is x to the 0, right? But what is this if I simplify? It's the number 1. So that's why any number raised to the 0 is 1. Unless you do 0 raised to the 0, then you run into problems. To answer the question 0 to the 0 or 0 over 0 or infinity over infinity, to answer those questions, you need calculus, and calculus allows you to do that. And the answer is not the same every time. No. Well, each problem is different. So it's not all infinities are the same size, and not all functions reach 0 at the same rate. So calculus allows you to do that sort of mathematics. It turns out it's really, really easy to do. It's not very difficult. Calculus is a wonderful, wonderful subject. All right. All right, negative exponents and fractional bases. So what this is saying is, so I can sort of distribute this to the top and the bottom. It's not called distribution, but it sort of works the same way. So 1 to the 4 over 3 divided by 8 to the 4 over 3. So let's do the bottom first. Can 8 be split into 3 equal multiplications? Yes, 2. So 8 is 2 times 2 times 2. How many of those 2's will be in my answer? 4 of them. So if we add another 2, I get 16. Okay. What about 1? Can 1 be split into 3 equal multiplications? 1. 1 times 1 times 1. How many of those are in my answer? 4. So the answer is just 1 over 16. Okay. And if instead of 1 on top, it would have been 27 to the 4/3. This is 3 times 3 times 3. We put another 3 in there, and then it would be 81 over 16. Okay. All right. What about this? What's happening here? We don't like negative exponents. That's one of the simplification rules. Do not leave negative exponents. So how do we fix that? We take the 25 over 1, and we flip these. And now I get 1 over 25. And what effect does that have on the exponent? It makes it non-negative. Good. So that becomes 3 over 2. Okay, and then you distribute it. You get 1 over 3 over 2 and 25 to the 3 over 2. And the 1 is just going to be 1. What about the 25? Can 25 be split into 2 equal multiplications? 5 times 5. How many of those are in our answer? 3 of them. And 3/4 makes $1.25. Okay. You can do this in a little bit of a different way. What if we just treated this? Can this be split into 2 equal multiplications? 1/5. So this is 1/5 times 1/5. That satisfies this. And how many of those are in our answer? 3 of them. So that's another way to think of it. You can distribute the exponent if you want to, or you can just treat it as its own fraction. All right, here we go. So let's do the bottom first. We're going to use the product rule. So what do we do here? X to the 1/4 times x to the negative 1/2 is the same as x to the 1/4 minus 1/2. Right? What is 1/4 minus 1/2? Negative 1/4. Right? Okay. So that gives me x to the 1/3 divided by x to the negative 1/4. I don't like that negative exponent. So I'm going to swap this up there, and I get x to the 1/3 times x to the 1/4. We use the product rule again. That is x to the 1/4 plus 1/3. So that is x to the 3/12 plus 4/12. So x to the 7/12. All right, let's do another one. All right. So on the bottom, z to the 1/4 minus 3/4. 1/4 minus 3/4 is negative 1/2. And then I'm going to move this up top. Z to the 1/3 times z to the 1/2. Well, it was negative on the bottom, but when I move it to the top, it becomes positive. So that is z to the 1/3 plus 1/2. So that is 2 over 6 plus 3 over 6. So z to the 5 over 6, which you don't have to write it this way, but remember, that is either this or this. And the only thing that matters, if z is positive, then those are totally equal. If z is negative, then you might run into some problems. So that is assuming that z is 0 or larger. All right, that's it. Get to work.